I just realized the government is back open and I'm doing a slightly controversial topic. Please don't call the FAA on me. I'm trying to be your helper here. I'm trying to do better for general aviation. Hello and welcome back to the Open Source GA channel. If it's your first time, drop a comment down below, say who you are, and say what you're trying to get out of this channel. I actually do read and respond to all the comments. I try to at least. And if you just give me some insight, it probably will spark something in my brain and I can grab it, I can run with it, maybe deliver more value to you. So the OGs, the people who've been here forever, the people who've been here since day one, you know, Colin Chappell and, you know, Michael Carter, all of you all also hop into the comments and make all these new people feel welcome. We are trying to build the best aviation community on YouTube, and then extend that community out to all the other channels that we follow. The Bonanza Pilot, the Rusty Pilot channel, Russ Can Fly, Alpha Kilo Warrior channel, you know, Chili Dog Pilot, Blair Craft, like all of these folks, we're gonna start expanding and making sure that you are connected to the entire aviation ecosystem, because we all have similar problems. And that's why you clicked on this video. You clicked on this video because the title says something like, parts are hard to find, or let's solve the parts crisis, or let's do an example of a parts crisis, something or the other. I've got to figure out the title of the video. Behind me is a 1963 Beechcraft Bonanza Model P35. You've been here a long time, you know this airplane. It's my airplane. If you're brand new, welcome. This is my airplane. Let's do an academic exercise. And before I get into it, here's a disclaimer. I am not an A&P. I do all of my work under the guidance of an A&P, the supervision of an A&P, a few A&Ps actually, some of whom you will see in these videos, some we don't talk about, some will remain nameless, but at the end of the day, I'm doing this work supervised by A&Ps, having casual conversations with them about what we can and cannot do with small airplanes. The advice and instruction that I'm giving to you here is academic in nature. I'm just saying this is something that we could do, not something that we should do. And before I get into it, you should know that at the end of this project, I'm not going flying with the thing that I'm about to show you, at least not yet. I am going to have a really in-depth discussion with my A&P to figure out the pathway to make this strictly legal to put on the airplane. So we have been flying these airplanes for a very long time. This Bonanza was designed back in the 1940s. It's gone through some iterations and some changes and, you know, parts upgrades, but we've lost a lot of the tooling, the molds, you know, the designers, the people who built these things by hand back in the day. We've lost a lot of that knowledge. And now you and I are struggling to replace parts on airplanes like these because those tools no longer exist. I'm trying to propose to you that even though those tools don't exist, we have modern tools that can take their place. And the people who designed this airplane, their minds would be blown if they knew the kind of tools that we have access to right from the comfort of our own house or our own hangar. Let's walk to the back of the airplane and I'll show you what I'm trying to get into here. So these are the rotovators of the Bonanza. Very recently, a group of people were granted a prize from the American Bonanza Society for figuring out a legal way, an easier way to replace the rotovators on this airplane. So these things are happening out in the wild. I don't have the tools and the expertise or the time to figure out how to make myself a whole set of rotovators. So let's sink down a little bit lower and do a totally different academic exercise. This area back here on the airplane is called the stinger. It's just, you know, think about the stinger on a bee. It's just the pointed end at the back of the airplane. It ferries out the airflow that comes off the back of the airplane. Now, if you're paying attention, you may realize that there's something missing from the back of this stinger. And I didn't realize it until very recently. There's some screw holes right here. And there's a glass lens right here. I didn't really pay that any attention, but it turns out there's an aerodynamic fairing, a lens, a clear lens that's supposed to be coming off the stinger and just completing that shape. It's just gonna complete that shape, just like that. Just follow the tip of my finger. It's gonna complete that shape, and a clear lens is gonna go right there. Now, I looked online, and I can actually find the lens that goes here on eBay for like $200, or brand new, I could find it for about 160 bucks. So this isn't really a crisis because the part is available. But for the purposes of this demonstration, let's imagine that the part wasn't available. Let's just say, hey, I wanted to be able to fly this airplane, and it would not fly well if that part wasn't on the airplane, so the airplane's grounded. Crisis. Let's think about how we would approach that. So one of the things that I have access to at home, and I often bring it here to the hangar, is a 3D scanner. I've done a few videos before talking about 3D scanning and the magic that that brings for reverse engineering parts. Now, you should know that the FAA has given us guidance in the ACs, the advisory circulars, on how to approach an owner-operator like me. I own and operate this airplane. How to approach an owner being able to make their own parts through reverse engineering, and then through methods that the FAA administrator, the ultimate boss level person at the FAA, would find satisfactory to them. So standard parts, common materials, standard methods like CNC routing or turning it on a lathe. If you can be involved in that process and work with your A&P, you might be able to find a very simple way to reverse engineer stuff. So I came back here, I put dots all over the airplane, or all over the stinger. I used my 3D scanner to get a shape of the stinger. I did this several weeks ago, so let me see if I can find that footage, and I'll try to put it here. Right, so this has a 6/32 screw going through those screw points, and that's how we will set it up. 6/32. I really hope I found that footage, or this portion of the video will make absolutely no sense to anybody. So yeah, that's what we did. We put the tracking dots. We used two different, hobby home style 3D scanners that are incredibly accurate. We scanned it, and then I took that raw data, that scanned data, and I put it over into a piece of software called SolidWorks. You can do this with software that's called Onshape. You can do it with Autodesk Fusion. There's a bunch of other software out there that's either free or cheap. And SolidWorks is usually a professional level software, but I just found out they have really affordable subscriptions that you and I can use. And it's, dollars per month, and X dollars per month, not thousands of dollars, like tens of dollars per month, or maybe even tens of dollars per year. This video is not sponsored by SolidWorks, it's inconsequential. You can also download a free version of Autodesk Fusion, and you can get a discounted version of SolidWorks if you're an EAA member. Go out there and find the CAD software that makes sense to you. Now, you may have to put some money aside to send your daughter or your cousin or your nephew to university to figure out how to do CAD. That's okay. By the time they get out of university in 4 years, you're still gonna be flying this airplane and still being faced with the same issues anyway. So it's an investment in your future if you can put one of your family members or a friend through college to figure out how to use CAD and do 3D scanning and that kind of thing. Now, I'm only partially joking. You can set yourself up for success. You're gonna have this airplane a long time. Anyways, after all of that was said and done, I know I need a clear lens to go on the back of the airplane. Now, I do not have currently the ability to print a perfectly clear material. The 3D printer that I have at home, it's a $400 3D printer. That printer can print in translucent materials and the light will shine through, but it would not pass the clarity test that's required just for my own satisfaction. But I'm pretty sure if I look deep enough, there is a requirement for glass or transparent surfaces to be a certain amount of, have a certain amount of transmissivity or translusivity or whatever the word is. It's gonna have to meet that standard, and my 3D printer can't do it. So here's what I did. Let's walk over here. I did not set that up appropriately. I just 3D printed a prototype. Yeah, a prototype. That's all it is. I'm not actually putting this on the airplane. I just used this and it took, I don't know, maybe 30 minutes to print, but it's the exact same shape and the exact same size that I need to put on the back of this airplane. Let's hop over into SolidWorks. Let me show you how I got to this shape. Okay, let's start here. Blank canvas. I imported the 3D scan. I drew some lines. And here are the lines. Those lines are approximating the shape, the slope of the stinger, and bringing it to a sharp point. I know my cover, my lens, doesn't need to come to a sharp point, but it does need to follow the stinger tangentially if I want it to be a drag reducing product. After I had those approximations, I sketched out the shape that I wanted the stinger to have. This bottom curve is tangential to the bottom straight line, top curve is tangential to the top line, and then it just meets at some point. And I arbitrarily, and there's no science to this necessarily, I said I wanted this point to be about here. I didn't want my stinger to be all the way out here, I want it to be about here. After that, SolidWorks lets me connect those lines. Oh, I also had to approximate the shape of the back part of the stinger where I wanted it to mount. SolidWorks lets me connect those drawings in a loft. And then I shelled that loft to make it empty on the inside. I mirrored it from left to right. So I created a complete part, left and right parts. And then after that, I just punched the holes where the screws would pass through. Because I can see in my 3D scan, let's hide this, I can see where the screws should be. And this is not a high resolution scan, this is like the cheap 3D scanner that I use, the $100 Creality Ferret that I got on Facebook Marketplace. So even with that resolution, I could still see where the screws go, and I have a really good approximation of where the hole should be. Now, if I were putting this onto a different airplane or I didn't have this data, I wouldn't put the holes in, I'd just match drill them. But yeah, that's how we got to this point. You take this, you save it as a certain file, you upload it to the internet, and like 1,000 different places can print this for you. That's as simple as it is. All right, back to the video. Yeah, after you do that, you have this. I clicked print on my printer and it printed this out. Because I 3D scanned my actual stinger, I put the screw holes into the part itself. So it's already has the holes for the screws. Now, with this prototype part, I was excited. I couldn't sleep that night because I was just so excited to come out here and try it and test fit it. And so I did. I drove out to the airport the next morning, and I came out here. Let's go back down here. And I went, kablam. There's no movie magic here. It just fit. It just worked. So without measuring too many times, without doing a whole bunch of extra work, just using 3D scan. And yeah, I spent some money on the 3D scanner. When I bought it, it was $1,000, but I actually used my $100 used scanner to do this. So just do that again. There is that aerodynamic fairing, and the screw holes align. I don't even have to tweak it. The screws would just slot right in perfectly. So now we have a problem. I know that my design is good. I know that my design will fit because I've just spent, this is maybe 50 cents worth of material. I've spent 50 cents in a couple hours making sure that that part fits. And again, here's a reminder. We're talking about this part right now. You can replace this with practically any part. It takes a lot more work to do, something more intricate, but I'm not talking about structural parts here. I'm talking about like little aerodynamic fairings. If you're looking for structural parts and you get a DER involved and someone who knows engineering, and maybe that $3,000 part that you've been looking at on eBay, You could spend $3,000 hiring a professional to make that same part. Now, maybe that might not save you money, but you'd have a brand new part and maybe some engineering that you can use to help other people get their airplanes up and running. Another thing that's going to pop up in the comments is, well, you need PMA and blah, 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 and all this stuff. I'm not selling this part. I have no intention of selling this part. I'm doing a thing to improve my product. I'm allowed to do that. The FAA says I can. We will have to go through a lot more paperwork to ensure that I can put this legally onto the airplane. Well, not this, but you get where this is going. This is an academic exercise. This is purely academic. So we have a problem. This is black. This won't transmit any light. I don't have a tool that will print clear, but online services do. I went online to this company called PCBWay. It's PCBWay.com. I think they're based in China. Nothing wrong with that. They're just really good at producing parts. They have CNC services. They've got 3D printing services. They've got bending and sheet metal services, just like SendCutSend does. SendCutSend does not do 3D printing yet. Maybe one day they will. So I sent this part off to PCBWay, and maybe I can show you the receipt here on screen. And what showed up was this. Let me hold it up to my face, because then you can actually see that you can see the reflections are gonna throw you off, but it is clear. It's a clear 3D printed part. And this part is the exact same as this part. This was my prototype. This is now the part that in the real world I would intend to put onto this airplane. Let's go see how it fits. Also, my knees are really weak and getting up and down here. I'm doing this for you. Okay. Well, oh, there we go. It fits. It fits really well. The screw holes align. The part is thin. It's clean. It's printed really, really nicely. It fits. So I can go have a conversation with my AMP to figure out if this will pass the litmus test of what the FAA wants us to do, to figure out if we can put parts that we make onto this airplane. Now, this material is not Lexan. If this was Lexan, or the stuff that windows and landing light covers are made out of, if it was Lexan, this would be a no-brainer, because I could just write up and say, I was involved in the design and manufacturing of this part, and here is the material that it's made of. And that material is a standard aviation type material that's used in other places. So we have enough data on this part and the performance of this part to put it onto my airplane. I don't know how this part holds up to heat or to light. Does it get really yellow over time? Will it melt? Will it crack? I'm sorry, you're transitioning outside. It's going to be really bright for a while. But to solve that problem for myself, I didn't just have SendCutSend or PCB make me one, they made me two. And it comes wrapped up just like this in a nice little box. And what I'm gonna do is put this part through some level of testing. I'm gonna leave it outside in the sun for a few days. I'm gonna take the other one and scuff it up and then spray it with a UV resistant clear coat. I'm gonna heat it up with maybe a little oven or a handheld heat gun and see how it performs in the heat. I may put it in the freezer and see how it performs in the cold. I may, squeeze it a little bit and see how it just reacts to general forces. This thing isn't structural. It's not holding up the airplane. If it falls off or it breaks, it's not gonna affect anything about the airplane, which is one of the litmus tests that we have to clear if we want to be able to make our own parts. It's one of the ways you tell whether a thing is a major or a minor modification, whether it has appreciable effect on the weight and balance of the airplane, which this thing weighs nothing. It's a plastic cup, right? Like nothing. If it fails, can you continue to fly the airplane safely and land safely? Yeah, totally could. And And does it change the performance of the airplane? I'm not going to pick up any speed or stall any slower by putting this on the tail cone of the airplane. I know that for sure. That's pretty reasonable to assume. Now, if you can clear those hurdles, then you can consider this a minor modification. But the final hurdle that I have not been able to cross yet is whether this material is, let's say, aviation grade or worthy of the CAR 3 aviation standard. Will it stand up to the scrutiny of the FAA administrator if something were to go wrong? If someone were to run into the back of my airplane, will they say, well, this thing isn't aviation specific enough, so you lose your lawsuit, you don't get any money? I don't know, I'm just making this stuff up. But we've gone through the entire process from defining the problem or the opportunity, which is a part that's not available. Again, that's not true because I can buy this online. The better option would be to go and buy this online. And then making this part. Just think about it. I can buy this part $160. I have a $1,000 3D scanner, $300 3D printer. I spent, let's say, I don't know, 20, 30, 40 bucks on this thing. What's my time worth? Blah, blah, blah. Well, it's definitely costs a lot more than 160 bucks. But that is because this part is available. If this part was not available, all of that effort, the 3D scanner, the CNC work or the 3D printing would totally be worth it to me to be able to keep my airplane up and flying. So this was a really cool example. I'm really hoping that you got something useful out of this video. We're gonna do more of these. And maybe I don't take it all the way to the end because, I was talking to the senior pilot or the senior flyer in the comments on one of my members only video and trying to get some insight from my members on how to present this type of information to you. Because it's very apparent that a lot of people, especially not the followers, that the people that just pop in here periodically, they have a lot of energy about this kind of stuff. Because someone on a forum somewhere said something to them 20 years ago and they just held it as the gospel. You can't make your own parts. You can't do your own interior. You can't do all this stuff. And none of that's true. Well, not none of that. A lot of that is incomplete information. They're talking about very specific cases. I'm not going to be able to go and make my own engine mount or my own landing gear struts. I'm not qualified or capable of doing that. But an access panel on the bottom of the airplane, a little lens for my Stinger, something that's inconsequential if it falls off or fails, I think we should be involved in that process. And there are legal ways to do that. The FAA has given us advisory circulars, which are in the description of this video, policy letters. They've given us regulations that say, yeah, we want you to do this. They've handed us a tool like VARMA for keeping vintage airplanes flying. They've given us a tool like NORSEE, where it's a much reduced scope to certify safety-enhancing equipment. This doesn't enhance safety, but if there was a stall horn or a stall whistle in the back here that enhanced safety, maybe I could certify this under NORSEE. I have a good friend, Mike Black, who's very familiar with how to do this type of work. I'm going to reach out to him to do an episode on the Open Source GA channel. I also have a really good DER friend, and he's also going to reach out and do a little video on the channel. So we're gonna solve some of these problems. We're gonna answer these questions, not once and for all, but for very specific cases. And then you can go off and find your own professionals to try to do the exact same thing. Okay? I'm trying to give you the tools here to be creative and imaginative in how we're gonna keep these things flying. So your sons, daughters, nephews, cousins, neighbors, a random person on the street that you've never talked to will eventually be able to own this thing 20 years from now and keep it flying because we have the tools and the technologies to do so. Let's stop creating excuses. Let's find solutions. Stop listening to the folks who have no investment to give here into general aviation. Maybe they've given up flying. Maybe they've never flown an airplane at all, but they're so tuned in to what someone else has told them that they call it the gospel and the truth. And it's typically not. Is this thing going on the airplane? Not yet. I got some more work to do. Could it go on the airplane? Yes, it could. Is it available? Yes, it is. Am I going to use this exact same part? You know, we'll see. That's what this video was all about. I hope you found some inspiration. I'm going to pick another random project to do on this airplane. I just did the whole headliner and that little back shelf area right there on my finger. I did that myself. It's upholstery stuff. Pilots and owners can do that kind of thing on their own. Let's see where this video goes. Like and subscribe. Maybe post it on a forum somewhere where you're trying to drum up excitement about general aviation. You know, let's see how we can turn these things into opportunities. And maybe I'll just pick a different project to work on. I don't know. Go check on your neighbors. It's the fall. It's going to get cold. People get hungry and lonely during Thanksgiving. Be good to a stranger. Call your dad. And we'll catch you later. Okay, I couldn't resist just putting it on the airplane to see what it looked like. And it looks really good. I'm moving the entire airplane by bouncing. I'm moving the entire airplane right now. That thing ain't, that ain't going nowhere. It does look really good though.